And continue with section 10.3. Doing a few more examples. Income 1. Evaluate. F dot dr, where this is the vector field F. 3 plus 2xy, x squared minus 3y squared, and this is the curve C, parameterized by this. Okay, try this out. Okay. Yep, bye. Let's see. You do partial derivative with respect to y of 3 plus 2xy. So this has to be partial derivative equal to x x squared minus 3y squared. So what do we have? We have a 2x equal to 2x. Yes, f is conservative. And the cool thing about the conservative is that you don't have to go through the integration. Okay, so fxy. Okay, so we know that fx is 3 plus 2xy. And integrate with respect to x. Do that, we have fxy. Integrate with respect to x, 3x plus x squared y. And then also don't forget that constant c, right? Constant c is the function in terms of y. If you forget a constant c, it's not good. Like fy is x squared plus g prime y, and then you got to set it equal to x squared minus 3y squared from the vector field. Okay. G prime y is equal to -3y squared. Integrate with respect to y. Gy is minus equal to 3. It is not necessary to do the plus c here, right? Okay, so that's it. We we have fxy. Three x plus x squared y minus y to the 3. Okay. Next is the we're going to use the fundamental theorem of line integral. If you apply that, integral f dot dr is the same as, well, f of you have 2 points here, right? Or pi minus or 0. Oh, how nice. So we have f or pi. Okay, oh man, should have done this before. I plug it in here. E pi sine pi, e pi cosine pi. Minus f of, okay, I'm gonna write right here. E0, sine 0, E0, cosine 0. F of, well, 0 and negative e pi. F of 0, 1. Three times 0 plus 0 square negative e pi minus negative e pi to the power 3 minus, oh man, I was able to have the minus sign straight up. 3 times 0 plus 0 square times 1 minus 1 to the power 3. So what do we have here? It looks like we have a e to the 3 pi minus 1 is the plus 1. Evaluate f dot dr, where this is the vector field f here. Yz, xz, xy plus 2z or t. No, I'm not gonna parameterize it for you guys. C is a line segment from 1, 0, negative 2, 2, 4, 3. Direct computation. Okay, so for the direct computation, it's pretty straightforward. Okay, so you just have to parameterize C here. Okay, so if you parameterize it, x equal to 1 plus 4 minus 1 is 3, t, y is equal to 0 plus t z is equal to 4 negative 2 plus 5t. Yeah. No, actually, it may be longer though. It may be longer. Not guaranteed it's going to be shorter though. Okay, yz. Yeah, maybe longer. No, but you got to go through it to see xz. xy plus 2z. Oh, dang. Two. Okay. Dot. Derivative of this one. Actually, let's do this then here. X prime is 3. Y prime is 6. Z prime is 5. So, oh, not too bad. 3, 6, 5. T. It's a lot of algebra, but it's not that bad. Okay, well, what do we have? We have 3 times 6, so that would be 18t minus 2 plus 5t plus 6, 1 plus 3t minus 2 plus 5t, and then 5 times this one is gonna be 5 times 6 is 30t, 1 plus 3t, 5 times 2 is 10 minus 2 plus 5t dt. Okay, simplify this sucker here. See what we have here. Negative 32t plus, okay, so 80t square 6 plus 18t. Oh, actually, I'll just FOIL it out before I distribute them sit in here. Okay, minus 2 oh, 3 times 6, yeah, 18. All right, thank you. 18 times 2 is 36. 18 times 5 is 90. Minus 2 and 5 minus 6 is negative t plus 15t square. Okay. 30t plus 90t square. Oh, they don't cancel out. What? Minus 20 plus 50t. Okay. dt. Minus 36 plus 30 plus 50. So 80 minus 36 is 44 t. 90 plus 90 is 180 t square. And then this one is going to be minus 12 minus t plus 90 t squared minus 20. Okay, so we have a 270 t squared. 44 minus 6 is plus 38 t. And then minus 12 minus 20 is minus 32 et. Okay. Woo. Okay, so 270 divided by 3 is the 90. T to 3. right here, under here. 38 divided by 2 is the 19t squared minus 32t 0 to 1. And what do we have here? 90 plus 19 minus 32. Yeah. 77. This is a nice formula here. Yeah, I still want to show you the second method though, because this is a nice problem to show you that, yeah, you can do either way, right? It doesn't matter which way that you do. So you can only do method number 2 if f is conservative. Right? Okay, so here come method 2. If f is conservative, use fundamental theorem apply integral. Three of them. Make sure that they are the same. ZZ, Y, Y, X, X. Good. In case you want to know what the heck am I doing here, I just do this fxy, I'm gonna show that is equal to fyx, right? And this fxz, I want to show that is equal to fzx. This fyz, and I want to show that it's equal to fzy. Right? And they should be the same in order for f to be conservative. Okay, so once we know it's conservative, then yay! And move on to figure out the function f. Okay. Well, doesn't matter how you begin, right? I usually begin at fx, but then you can begin at fy, fz, and up to you. So fx is the yz, right? Integrate. With respect to x. Fx, yz, yay! With respect to x, gonna be a x, yz plus, okay, so we treat yz as the constant, so we're gonna get a function in terms of yz. Yeah, already okay. Just treat y and z as constant. Okay. So next is the with the used information on fy, right? Fy xz plus, well, you're taking the partial derivative, right? So it's going to be a gy. Right? And this is going to be a, what do we have here? Fy is xz. This is the from a vector field f. Right? Because this is conservative. Okay. So gy is equal to 0. What does this mean? You got to integrate both sides with respect to y. You do that, you're going to get a gy z. And gy z is equal to, it's the constant c, right? But then that constant c is going to be a function in terms of z, because we treat z as a constant when we integrate with respect to y. So it's going to be a gz. Everybody okay here? When you integrate with respect to y and the function is gyz, you treat z as a constant. So gyz is equal to g of z. Or you can write h of z here. Doesn't matter. I use h of z here. Less confusing. Next. Well, we got to do fz, the last one. So fz, look at fxy here. Z, it's going to be xy plus gyz is hz, so it's going to be h prime z, and this has to equal to, xy plus 2z is the last component. From the vector field f, almost done here, right? H prime z is equal to 2z. So from here, you can get integrate with respect to z. Hz is z squared. Remember, you can set c to be set c equals 0. Okay, to do that. Yeah. So that means so fxy z is equal to xz xyz plus hz is z squared. And if we do that, then the line integral f dot dr is 4 times 3 plus 3 square minus 1 times 0 times -2 plus -2 square. Okay, 4 times 3 is 12, 12 times 6 is 72 plus 9 minus 4. Oh, 72 plus the 5 is 77. Yeah. Oh man, the answer match.